Welcome to another video. We have an Olympiad question before us. We have open parenthesis, the square root of 5 plus 2, close parenthesis, raised to the power of x, plus open parenthesis, the square root of 5 minus 2, close parenthesis, raised to the power of x is equal to 18. We are required to find the value of x. So let's begin. Alright, before we start answering the question, I would like you to consider subscribing to this channel if you have not yet subscribed. On this channel, we simplify mathematical problems. Now let us answer the question. The terms in the parentheses represent a difference of two squares. Okay? Here, we are going to introduce the square root of 5 plus 2 to enable us make a substitution. To do so, we will first multiply the terms in the parentheses. Root 5 times root 5 will give us 5. Root 5 times minus 2 will give us minus 2 root 5. And here 2 times root 5 will give us plus 2 root 5. Plus 2 times minus 2 will give us minus 4. So we will have 5 minus 4. And this is equal to 1. So we have that the square root of 5 plus 2 times the square root of 5 minus 2 is equal to 1. Now, let us divide both sides of the equation by the square root of 5 plus 2. This will cancel with this. We have that the square root of 5 minus 2 is equal to 1 divided by the square root of 5 plus 2. In the given equation, we will replace the square root of 5 minus 2 with 1 divided by the square root of 5 plus 2. So we have the square root of 5 plus 2 raised to the power of x plus, let us distribute this power of x to the numerator and the denominator. In the numerator, we will have 1 raised to the power of x divided by, in the denominator, we will have the square root of 5 plus 2 raised to the power of x. And this is equal to 18. So we have the square root of 5 plus 2 raised to the power of x plus 1 raised to the power of s is going to give us 1 divided by the square root of 5 plus 2 raised to the power of x. And this is equal to 18. Let us replace the square root of 5 plus 2 raised to the power of x with a variable. Let's consider variable y. If we make this substitution, this equation will become, here we have y plus 1 divided by y. And this is equal to 18. Let us get rid of this fraction by multiplying the three terms by y. So we will have y squared plus y will cancel with y. We will have 1, and this is equal to 18y. Let us equate it to 0. We now have a quadratic equation. We are going to use the quadratic formula to solve for the values of y. Okay. Here we have the quadratic formula. A is the coefficient of the first term, which is 1. B is the coefficient of the second term, which is minus 18. And C is the third term, which is 1. Let us input these values in this formula and solve for y. So we have y is equal to minus times minus 18 will give us 18 plus minus. Minus 18 squared will give us 324. Minus 4 times 1 will give us minus 4. Divided by 2 times 1 will give us 2. So we have y is equal to 18 plus minus 320 divided by 2. We can split 320 as 64 times 5 divided by 2. We have y is equal to 18 plus minus the square root of 64 is going to give us 8. So we have 8 times the square root of 5 divided by 2. So we have y is equal to 18 divided by 2 will give us 9 plus minus 8 divided by 2 will give us 4 times the square root of 5. We have that y is equal to 9 plus 4 times the square root of 5, and y is equal to 9 minus 4 times the square root of 5. Okay. Recall that we made a substitution. The square root of 5 plus 2 raised to the power of s is equal to y. Since we have two values of y, we are going to have two cases. Okay, now let's consider the first case. The square root of 5 plus 2 raised to the power of x is equal to y, and y is 9 plus 4 times the square root of 5. On the right hand side of this equation, we are going to generate an algebraic identity from this expression. Okay, a squared plus b squared plus 2ab is equal to a plus b squared. We can write this 9 as 5 plus 4. Then we have plus 4 times the square root of 5. We can express this 5 as the square root of 5 squared. Okay, plus we can express 4 as 2 raised to the power of 2. Okay, and here we can express 4 as 2 times 2. Okay, times the square root of 5. If we compare this algebraic identity with our given equation, you will notice that the square root of 5 is represented by a, while 2 is represented by b. Okay, here we have the square root of 5 squared, which is the same form as a squared. And here we have 2 squared, which is also in the same form as b squared. And here we have 2ab, which is also in the same form as 2 times the square root of 5. In our given equation, we will replace the right hand side with this expression, since this expression is equal to this expression. So this equation will become the square root of 5 plus 2 raised to the power of x is equal to, instead of this, we are going to have this. We will have the square root of 5 plus 2 raised to the power of 2. Here we have a common base of square root of 5 plus 2. Okay, since the bases are the same, we will equate the exponent. If we equate the exponent, we have that x is equal to 2. In the second case, we have the square root of 5 plus 2 raised to the power of x is equal to y, and y is equal to 9 minus 4 times the square root of 5. If we simplify this will give the value of x as minus 2. This will not satisfy the equation, so we will reject this. So s is equal to 2 satisfies the equation. Thank you once again for watching this video. If you find this video helpful and informative, please subscribe to my channel. And do remember to like, comment, and share. All the best.